Hello friends, feature scaling is an integral part of feature engineering for the numerical data. First, we need to understand why do you need the scaling of the data. The standard scaling actually improve the performance of the model. As the estimator model expect the data to be centered around 0 and has the same variance level. Why? Because if your feature has the difference in magnitude of the variance, then the feature which is having higher magnitude of variance will dominate the objective function, and the estimator model will fail to learn from the other features. So now let's discuss the standard scaling technique given in the scikit-learn library. So it uses three things. First, the value of the feature. Second, the mean value of the feature. And third, the standard deviation for that particular feature. And the formula it uses, x scaled is equal to x minus u by s. So it actually removing the mean from the value of that feature and then dividing it by the standard deviation. Now let's look at our example to see this in practice. Let's first import the standard scaler from scikit-learn pre-processing library. And I imported numpy as well. Now let's define a scalar. And I have not given any parameter, though it has very minimum amount of parameter, but let's first check the parameters. What are the default parameters? Using get params, and I have not defined it. First I need to run it and then I define it. Yeah, so it has two parameters with mean. That means before scaling you can make the data centered around 0. That means all the data, all the features will have like 0 mean, and with standard means you have the unit variance is equal to true, and you can change it using these parameter value as well. So if you want to avoid any of these, so mostly people avoid like the data centered around 0 in case of sparse matrix where you have too many 0 records. Like in Amazon you check like your preferred shopping cart or what you are looking for. So there are so many entries in the Amazon databases for the items to be sold, but your preference is very small data set with respect to it. So it is a like example of sparse matrix where like centralizing data is actually a too much effort, so people avoid it in case of this sparse matrix kind of data. Let's now fit the data like scalar dot fit, and you need to first define the x train and then like fit the x train, and now you can check different attributes like what is your mean in x train. So that is mean underscore, not x train, it will be scalar, my mistake. Yeah, you see, this is not having like the zero mean for all that features. So if you just transform the data, you will achieve the zero mean. Like, and make it like a name x is equal to, and then you just print x. And you see the mean value for these features are now 0. You can check it using the x mean. Yeah, and if you check the standard deviation also, you see the standard deviation is 1, so it is of unit variance. And before doing the scaling, you can check that what is your variance before doing the scaling, the standard scaling. So you can check it using the var attribute. So you see it has no unit variance, the variance is different. Now it has given also like per feature what is the relative scaling of the data to achieve the zero means and unit variance. So that is given by scale. So it is usually a square root of this var attribute. So you see, so this is like per feature what is the relative scaling of the data. And once you achieve this, like you can scale the data. So you can check mean, scale and var, and then you can like transform your data and you can check the standard deviation and the mean. Thank you so much for watching this video. Please leave a like and subscribe for more videos like this, and please leave your doubt or any question or any particular comment about this video or about this topic in the comment section below. Thank you so much.